for them. So big questions is what is meant by data type. So data is information. And on computers these days, there's a lot of different kinds of information. So the big types I mentioned the other day were number is a kind of data type. But then there are different kinds of numbers, like whole numbers or integers or decimals. A single character you type is a data type, like the letter A or the numeral 1, the @ sign, the pi symbol. And we can put those together and get a string of characters. And we often call those words or sentences or paragraphs, but in computer language, we call the strings of characters strings because we're stringing them along. So number is a data type, string is a data type, but there's lots of other data types that we deal with on computers these days, like sound, video, images. Those are all the kinds of data types. Are there other data types out there? Absolutely, but those are the main ones. What types of data or what data types are available in Scratch? Does anybody remember what kind of data type Scratch can play with?
Numbers, booleans.
Yeah. Strings, characters, and we do use images, but not quite as data. And by that I mean things that a variable could take use of. Okay, so I can have a variable be a Boolean, true or false. I can have a variable be a number. I can have a variable be a character or a string. Right, so those are the main ones Scratch has. What's a variable? Well, it's a little different in math. It is a named place where we store information. What kind of information? Data. What kind of data? Well, a number or a string, typically, of what we're going to put in there. And then there was the idea of scope, which came up in a couple of different ways. The main way we looked at scope in Scratch last class was that when we make a variable, that variable can apply to all of the sprites in the script, meaning they can all control it, change it, or it will apply to just an individual sprite. And we saw that it matters how we do that sometimes, right? That our clones didn't behave right with a global variable, but they did with a local variable, meaning with that sprite only. Where else did we come across scope? Anybody remember? What did we do last week? Starts with a P, R, almost procedures which use parameters. Yeah, so parameters of procedures are scoped within that procedure. So if you try to use one of those parameters in a different procedure, it does not work because the other procedures don't know about them. They're scoped, they're stuck in that one right there. Okay, and I'll show you an example of how that's easy to mess up and it's easy to fix too, most of the time. Okay, so I want to go back and take a look at my clones and global variables. Remember, we took the example in the book and we amended it by having the clones say a clone number. I'm number 1, I'm number 2, I'm number 3, and so on. And I mentioned we could name the clones, like I could call one George and one Bo and one Momo and one Zumi. And I said one way to do that is with lists, which we'll get to later, but it turns out there's another way we can do it. So I'd recommend playing along with me. So if you want to try this with me, then go get your version of clones and global variables. So I'm going to open up mine and I'll show you how I amended it and we'll talk about it a little bit. So clones and global variables was one of the reading assignment problems we did last class. Here's my new version of it here. And you should see it looks a little bit different than your version. And I'm just going to rewind a little bit on that by showing you the examples in the book that we were trying to follow here. So in the book, get the right page. There we go. So it was the section on clones and global variables. And what we did is we took parts of clone ID, which was set the ID, change the ID, say the ID as a clone. So we basically took 3 lines out of this script and stuck it into this script right here. Okay, so that's what we tried to do last class. That was part of the reading assignment to do that. And so the clones popped up one at a time, said, hey, I'm number one, I'm number two, I'm number three, and so on. So now what I want to do is I want to give them a name too. And a way to do that without lists is to just do the ask that we've tried before. Remember, we tried the ask when we were doing the temperature last week. We're going to do it again this week. So back to my version. So we had developed pretty much this the other day. I think we play a little with color in here too, and other people did a lot of other fun stuff. So what I added to this was inside the repeat, I put an ask, what should my clone's name be? So I went over to, let's move that, the sensing. And I took the ask, what's your name? I dropped it in there. I just changed the question. Okay, so if you want to try that on yours, go for it. The other thing I put in here was we had a random weight in the other one. I was playing around with different versions of that, and I decided to put a weight in the repeat loop. So that's a little different than maybe what you and I did last class. Some things I did to change when I start as a clone. I ended up needing to use 2 of those because I wanted before the clone just stuck to the screen in one spot and didn't move. I decided to make him move a little bit, like a previous example. So I added in a pick random point and direction, pick random number. So again, that would be from the motion point and direction. So I dropped that in. And then from the operators, I grabbed the pick a random number. So I put those 2 in there. And then I changed the way I did the say. So I'm just gonna move this over a little bit. And I'll show you how I put this together. So I'll start over on that. I'll start from scratch. In the look section, instead of the say for 2 seconds, I want them to say for the whole time what their name is. And I wanted them to say both their name and the number they got, because I'm still using the number to let the game run. Now, we talked about operators the other day, and when we were talking about operators, we were thinking about operators like addition, subtraction, multiplication, and division, things we do with numbers. Somebody asked about Boolean operators, and those are like the less than, the greater than, the equal to. But we also have string operators, and a string operator is a join. So from the operators, I'm going to grab a join, and I'll show you how we use a bunch of joins to write a sentence. There's a homework problem where you're going to do something very much like this.
I was just playing around with that.
Yeah, it's pretty fun. Yeah, so join is essentially a string operator. It just sticks 2 strings together. So if you, for example, have, say, join apple banana, click it, it's going to say apple banana. Now, if you don't put spaces in there, then they'll be merged together. And here I can see there's a space after the word apple. So I'm going to delete the space. If I click on banana, there's no spaces. I'm going to say it again. And you should see apple and banana are merged together. Joining strings like that is also called concatenation. I'm going to write that down in the notes, because you might hear about it or read about it in other places. And then I'll come back to how to make that saying there. All right. So what I'm doing at the moment here is I'm having I'm going to use a variable in a minute. Variable. And that, this pen is just freaking me out. That variable is going to be a string for the data type. So string data type. And one way we can operate on a string, so string operator, is essentially to add the 2 strings together. Now, operator, if you try to literally add 2 strings, Scratch is going to be very confused because addition is for numbers, not strings. So the string operator we're using right here is called join. And join takes 2 things to join together. And this is also called concatenation in other languages. Concatenate, which just means stick them together. It's a great word, concatenate. Concatenate, I like the sound of that. So in this case, I want to have a sentence that says, I am clone number, fill in the blank for the number, comma, but you can also call me, and then we're going to give it a name. And since the name is coming from the ask, oops, sorry about that. Since the name is coming from the ask, then I'm going to get the answer by using the, where'd it go, answer here. So I'm not going to create a new variable for this, although that could be a good idea. I'm going to use this answer variable from that immediate question. Now, essentially, my sentence has 4 parts to it. It's got the first part that says, I am clone number. The second part is the actual number. The third part says, but you can also call me. And the fourth part is the name. So that means I need 4 slots for my join to make that happen. Okay. And often for complicated things, it's not a bad idea to write it on paper first. So the way I usually do that is I put in a join and I start typing and hope it's going to work out. I am clone number. And then I realize, well, if I just put the clone number next, I got nothing else to join to. So I can't quite do that yet. I need some more spots. So I just go grab another join and stick it in the second spot there. Okay. So now I can go grab the variable for clone number. And then I can continue the sentence. And it's important when you're writing sentences to put in spaces. Otherwise, everything gets mashed together. Okay. So let's see. Did I remember to do that for clone number? I did not. So after the word number, I need to put a space. Otherwise, the number is going to be stuck to the word number, which is going to look funny. And then here, I need to do a comma space. But you can call me. You can call me. Now, I need another blank. Okay, so what's going on now? I need another join because I don't have enough blanks. All right, so I'm just going to highlight that, cut it out, get another join, stick it in, paste that back in, and then what are they going to be called? Not banana. I need a space after me, otherwise they'll be stuck together. And I want to grab the answer from sensing. And again, I didn't do a say for so many seconds because I want them to have that say stuck to them the whole time they're on the screen. Now, I wanted them to move around the screen, and the code from the book for that, if you looked at the previous example in the book, had in a forever block, move a random distance 1 to 10 steps. If it hits the edge, bounce. So it was forever moving and waiting to bounce. The problem with a forever is there is nothing you can put underneath it. It ends the code. My previous code said to have the clone number change and then delete the clone. I can't put that in the forever. That doesn't make sense. It has to go outside the forever. And I can't delete the clone before the forever because the delete ends the block too. So I had 2 things I wanted to have happen, both ending the script or that sprite's actions. So what I had to do is I had to make 2 different when I started to clone things, giving power to my clone. Okay, so one of them picks a position, tells it to talk and moves around. The other one says, wait 10 seconds, change the number of clones and then go away, just like before. Okay, so to use the forever block to move, I had to take the code we had before and put it in a new one I start as a clone. So what should happen now, if I put this together right, then when we click the flag, it's going to set number of clones to 5, clone number to 0, and then 5 times it's going to ask and wait. The ask is always a wait. So it's not going to make another clone until after I give the first clone a name. Then it's going to increase the clone number, make the clone. So now we have an answer and a number ready for that clone to say. Let's see if it works. So I'm going to blow this up and run it. Gary, Momo, Papa, Dim, dawn. And they're moving kind of fast, but everyone has a different number and a name attached to them. Okay.
Mine does it one at a time.
So again, that depends on other settings. So let's just go back and look at my code to see how I pulled that out. So that was a little crazy. I thought it was fun though. So just compare your code to mine. So again, I have ask and wait, and it's not going to go to the change clone number or create clone until after you hit a name and type enter. And then I added another 1 second wait before it makes another clone. And then inside, when I start as a clone, I have the same set x2 we had before, the same set y. I added the point in random direction. I changed the say for so many seconds to just a say without seconds. Okay. Otherwise, it's going to say it for 2 seconds and things kind of pause for a minute for that clone, and then it starts to move. Then it moves, and then I have it waiting 10 seconds before it gets deleted. Okay, so if yours differs from that a little bit, then it's going to behave a little bit differently. Okay, but what was the thing I wanted to get across here? That I can, using the ask and answer, give each clone a name immediately, and then each clone is stuck with the name it gets from that answer. Okay, and anywhere else, I bring that up in the code, it should use that. Now, here's a problem though with this one. Answer changes every like 1 second in the time it takes me to type a name. So maybe it takes me 5 seconds to type a name and hit enter. There's a 1 second wait. So roughly in mine, given the speed I can type, every 6 seconds answer is changing. So if we ask clone number 1 to say its name like 7 seconds later, what would it be using for answer? Would it be using the new answer, or to be using the answer it was given the first time? Okay, so that would depend on whether answer is a global variable for all sprites or only for a specific sprite. And I haven't tested that out, so I'm not quite sure. If it's a global variable, which is what I'm thinking it probably is, that means 7 seconds later, if I ask sprite number 1 to say what its name is, and I told it its name was, say, Gary, it's going to now go to whatever the next name is accidentally. So that could be a problem. So that's where I would need another place to save the name. So either another variable or a list of names somewhere. Okay, and we'll get to list of names in a couple of weeks. All right, so again, point of this was a couple things. One, using the ask answer as a variable collection tool. And two, how do you work with strings? One way to work with strings is using join. And when you use the join, you might have to have a bunch of them, depending on how complicated the phrase you're making is. And then you want to make sure you put spaces in the right spot so things don't get stuck together and it's readable. Right. All right, other questions on this particular example? Okay, let's move on. For question number 5, when you do your ask, say, give me a noun as the second one, please. You're going to go get the answer, but you need to hold on to the answer till after you get the article and the verb too. Now, where are you going to put it? Well, the only place to put it is a variable. So you'll have to make a variable for each of those. So again, I'm in my clones and global variables. I really should start a new script, but I'm just going to give this one example. So for each of the things I need, the article, the noun, and the verb, I'm going to have to vary a variable for them. So since I'm doing the noun right here, I could make a variable called noun. Now, if you want to make this more interesting, you could ask for adjectives and other nouns, a verb ending in ing, whatever you want to do. But minimally, you should have 3 things that you ask for, 3 types of words. For this particular one, it doesn't matter whether it's for all sprites or for this sprite only. So I'm just going to leave it for all. And then once I ask that, then I'm going to immediately have to set whatever I'm asking about as a variable, I'm gonna have to set the variable equal to whatever answer they give me. And I'm gonna have to repeat that block 3 times. I'm gonna have to do it for the article, and then I need a variable for article. I'm gonna do it for noun. I have a variable for noun. I have to do it for verb, do it for variable for verb. And then you're gonna make a multiple join statement to put all that together in an interesting sentence. Now, the most basic thing you could do is just put the 3 of them together and do nothing like this. Nothing like, maybe your article is the, and your noun is boy, and your verb is runs. So your sentence could be just simply the boy runs. You would just have to drop spaces in there. Okay, but I'm hoping you make a more interesting sentence than just that. But that's a possibility. Now think about that sentence for a minute. If you did go with the most basic sentence, write that down on paper. There's my paper over here. So I would have my article, which would be the, and then I need to put a space in there, and then I can get my noun. And then I need to put in a space in there, and then I would put in my verb. Okay. And it could be a different article than the, like a or an. And so how many things do I need to join together to make this happen? Right, so I can see that there are 1, 2, 3, 4, 5 things that need to be joined together minimally. So you're going to have to put enough joins inside of each other so you have 5 slots to put stuff in. Okay. All right, so have fun, write an interesting sentence. And when I look at yours, right, I'm going to run it and I get to put whatever I want in there and then see what happens. Okay. All right, next problem is number 6. And we've pretty much already done this. Last week, we did something just like this. We're going to write another program that converts a temperature in Celsius to Fahrenheit. We went over how to do the arithmetic. I'll review that in a second. But here we wanted to do it for any number given, which we're going to use the ask and answer part. So if you didn't do that last week, you're going to do it this week. Last week I had to do it just to make the problem a little bit more easier. This time it's required. Order of operations for this right here, we have to have a multiply that has to happen and then an addition. And we're going to do a couple of problems here where we play with that. And if I look at the scratch blocks for that, get rid of that.
I kind of did the reverse of this.
Yep. You,
Because I
in
was
terms of
playing
you did.
around, I remembered 1-7.
Oh,
what if
so
I
you
just
did.
join, do that.
Yeah, cool. Yeah. Let's see. I want my operators. So for that calculation, I need both an addition, oops, and a multiplication. And then the order that they have to happen is we want the multiply to happen and then the add. So that means the multiply needs to go inside of the add to make that happen. Okay, so I'm putting the multiply in the add to get that order of operations to happen. So, and the computer knows the order of operations, so it's going to do that multiplication and then try to do the addition. All right, next. We're going to do problem number 9. Now, problem number 9 is to have a box and to ask for a length, width, and height for the box, and then calculate the volume and the surface area. So I want to go over that with you. I highly recommend right now you take out a piece of paper and write this down with me. For those of you who had a lot of math, this might not be a big deal for you, but if you haven't had a lot of math, then this might be a big deal. And I find that good programming comes from good planning. So first thing I want you to do on the piece of paper is draw your best box on the paper. And there's lots of ways you might go about drawing one. So often I see people draw these by making like the front of the box and then kind of heading off at an angle to give the box another dimension. Top, come down for a side and do a similar angle for the back. Right, so that's an example of a box we might make. Now, that box right there, it's almost a cube, but not quite. The box could have any shape, and I'm going to offer a bonus on this one for anybody that wants to go for a bonus. Like, I just got a package from Amazon, and its box looked more like this. Now, sometimes when we draw these, we make them look see-through. So an alternate version of the box might be something like this, where I draw a skewed bottom like this. And then from the bottom, I come up the same height each time to the best of my artistic ability. Oops, a little too high there. So down a little higher. And then here. And then I got to put a top on. So here's like a see-through box, like a fish tank kind of thing. And again, we want to find both the surface area and the volume. Now, volume of boxes is pretty straightforward, and that's going to be the easiest part in Scratch here. Volume is just the length times the width times the height. I'm using asterisks for times here. And on my picture, I would say, let's call, say, this the length, and this one the width. And then this one here would be the height. Huh, thanks, Maddox. Maddox is making fun of my drawings here. It's more like Picasso boxes than Da Vinci boxes. And kind of another way to think about area of a three-dimensional object like this is the bottom has an area, right? So another way to think about it is we're taking the area of the bottom and multiplying it by the height. There's another way to think about it. Now, for the surface area, we'll just call that A for area. I call it SA for surface area because I already have the word area there. There's a bunch of different surfaces here. How many are there? Well, if I look at my blue one here, there's a top and a bottom, there's a front and a back, and there's a left and a right side. And the top and bottom are the same shape. Now, this one doesn't look it, but here, right? This top and there's a bottom I can't see are the same rectangle. The front and the back are the same size rectangle, and the right and the left side are the same size rectangle, right? So really, I only have three sides to think about, and then I need to just double it. Make sense? Okay. So for this face right here, its area would be for the way I've wrote them here, it would be whatever the length is times the height. And then this one over here would be the width times the height. Sorry, I'm having a really hard time with this pen today. And then the top part here would be the length times the width. And the book goes over this, but not with the pictures. With abbreviating that, I have length times width, and I have length times height, and I have width times height. And again, there's two of each of those. So I can either multiply each of those by 2, or I could put parentheses around that whole lot right there and double the whole parentheses to get the surface area. So that's kind of the easiest calculation, the less blocks you need to make that surface area calculation happen. Multiplication, addition, and the whole thing needs to get multiplied by 2. Okay, so I want you to try putting the blocks together to make that calculation happen. And then you can plug in some numbers to test to see what the script calculates, test it on a calculator, which is easier to use, and make sure the answers match, that you put the blocks together in the right way. If you get stuck on that, then let me know and I'll help you troubleshoot your calculation. Okay, but you're definitely going to have to test that. Now, if that's hard enough, cool, just do that, be done with it. If you want a bonus on this one, so let's see, red bonus for this one, extra credit. Draw the box to scale. What I mean by scale is if, for example, the height is twice as big as the width, then the picture should show the height is twice as big as the width. If the length is 4 times what the height is, then the picture should show that it's 4 times what the height is. One way to do that is when you input numbers like, I want the height to be, say the length to be 50 and the width to be 30 and the height to be 10, you could make the sprite move those measurements in the right directions. Okay, so it's up to you if you want to take on that extra challenge to have it draw a box with that shape. And again, that is one reason I wanted you to draw it on paper, because the way you go about drawing it on paper is similar to the way you're going to tell the sprite to do it. Okay. And then on Tuesday next week, I'll show the way I put together the drawing. I decided to use some procedures to clean up the code. So I'll give an example of that as another structured program next class. All right, next. Problem number 11. So problem number 11, you're going to be given, or you're going to get the code from Whac-A-Mole. And so you can either get that from me or from the chapter scripts if you have those downloaded. Again, if you need it from me, I'll put it in an announcement in a few minutes. And the Whac-A-Mole game comes with some code, and the code just moves the cat to a different black hole. Like he gets sucked in and then he pops up somewhere. I don't know if anybody ever played that game in an amusement park or a game room or anything, and you whack it with some kind of club. So the basic version of this is you're going to use your mouse to click on the cat wherever he pops up. If you miss, then you're hitting the stage, because this picture of the game is the stage. If you hit the cat, then you get a point for hitting the cat. If you hit the stage, then you get a miss. So every time you hit the stage, not the cat, it should add up a new miss. Every time you hit the cat, not a stage, it should add a hit. Okay, so the minimal version of this game is you're going to add code to the cat script that when you click on the cat, you get a point. And you're going to add code to the stage script that says when you click on the cage, you're going to get a hit. Okay. Add some sound effects to it, right? So you could add some music that runs through the whole thing. You could add a noise when the cat pops up, a noise when you touch the cat, and a different noise when you touch the stage to make it more fun. Another thing you could do to make it more fun, instead of just clicking with the mouse, you could get some sprite and attach that sprite to the mouse, like a hammer or a wand, and use that to do the whacking instead. In which case, instead of the mouse touching the stage or the cat, we're letting the hammer touch the stage or the cat. But again, let's just take a quick look at how that might happen. So I'm going to bring up my Whac-A-Mole and show you how I might get this started either way, and then you can continue it, and then we'll take a look at that broken game. Let's see, I want a new scratch so I don't lose the one I was playing with. And I am going to load from my computer the Whac-A-Mole. So if you haven't already done this, it's a good idea to do it now. There's Whack-A-Mole. Yep. And I'm going to call this Whack-A-Mole 2023 because I have another version of it I don't want to confuse it with. And then for anyone that needs a copy of this, I'm going to share it and put it in the announcement. That quick. Sample chapter 5 scripts. Whack-A-Mole. And then we want a link. Oops. Have to highlight that. And apologies if I didn't spell it the same way the book does. That's okay. All right, so the link is now in the announcements if you happen to need a copy of Whack-A-Mole. So if I run it right now, let's move this out of the way. The cat's just going to randomly jump around from one hole to another. So it'd be nice if there was some noise going on with that. So feel free to add that. Now what we want to do, and then try clicking on the cat. It's kind of got to be quick. Can't. Oh, I got him. Oh, got him. Yeah, so mostly you're going to find yourself clicking on the stage. Depends on how good you are with your mouse. So we're going to add 2 blocks of code. We're going to add a block of code to the cat so that when we click on him, right, maybe he makes a noise, and then we're going to increase hits by 1. Then under the stage, we're going to add some code to the stage so that when we click the stage, maybe it makes a different noise, and then we're going to increase the misses by 1. Now, you could add some other logic to the game, like if there's too many misses, the game's over, or if you get so many hits, you win, the game's over, something like that. That is optional also. What's that?
You see the comment that
Oh, no. So if instead of just the mouse, what if I wanted some other sprite to be the whacker? I'll show you how I would start that. I would just grab another sprite, and I'm going to grab the magic wand, I think.
So none of them look like a hammer.
You could make a hammer.
Oh.
So let's take a look at how I might make a hammer. This is kind of fun. I would draw in a hammer. And for a hammer kind of has a circular, and I'm going to look at it at kind of an angle. And then maybe I have a rectangular thing coming off of the hammer, something like that. And then I'm going to have another block for a handle, maybe something like that coming down. So that could be my hammer. And then I can tweak this a little bit. So maybe I'll go to the point. We played this a little bit, maybe in week 1. If I click on that right there, it's using the vector graphics version of this. And these points are movable. So maybe I decide it's a little too tall, so I can click on it, make it a little shorter. And it moves them separately. I'm going to put a point in the middle, and then I'm going to grab that point and move it down, and it curves it, which is kind of fun. And you can adjust how the curve looks with these little things on the end. So you could make a hammer some kind. Maybe this is my hammer. Yeah, look at that. It's a beautiful hammer. And then if you want it to be at an angle, you can highlight all of it together. And then, let's see, group them. And then where's my rotate tool? Come on, rotate tool, where are you? Oh, it's not going to let me rotate it? Oh, shit. Oh, I know. I've got the wrong button. Undo. I need this button here. Then I can rotate them. So now I got a hammer I can swing to play with the cat. Maybe that's a little bit too big. We could resize it. And the next thing I would do is I would position the spot I want the hammer to hit to the crosshairs, the center for that sprite. So then, and then I would attach it to the mouse. To attach it to the mouse, I would do something like this. Add an event when flag is clicked, control forever loop And then for motion, I would throw in the go to. Instead of random position, I'm going to go to the mouse pointer. So now when I hit the flag, it's going to follow me around, and I can try and click on the cat with the hammer. If you wanted to get a little fancier, you could do something like when you click the mouse, the hammer pivots. It could be fun. So there's lots of things you could do to play around. Stop. All right. All right, last but not least, let's take a quick look at the game. And this one is a download that you have to do on the screen, kind of like if you're borrowing the scripts I put in the announcements. And oh, I guess I got to hit the download button there. And broken hit game. I'm going to give mine an extra thing because I have another version of it sitting in my Scratch stuff. Now, again, I don't want to put it on top of the Whack-A-Mole. I want to make a new script and then upload that file. Otherwise, I'll lose what I've done for Whack-A-Mole. And go find the file you downloaded. And then I'm going to switch over to the project page on this. And I'm going to run it. Okay, so let's go read the instructions. Oh, I got one. Ah, interesting. All right, so there's me running the game. All right, so we're going to take a look at this. And in the game, when you click the ball, they take a hit, reducing their hit count until they die. The way the game was supposed to work, that each ball should take hits and die independently. What happened right now is I hit one of the balls enough and all of the balls died. That wasn't supposed to happen. Only the ball I clicked enough should have died, not all of them. Now, we had a problem like this last class when we were playing around with variables and whether the variable applied to all of the clones or just one of the clones. And we found a fix for that. So there's going to be a similar fix for this one. And it's not that hard. So the hint, we solved the problem like this last class when I was playing around with those clones and numbers. All right. So play it a few times, see how it works, look at the code, see if you can figure out how to fix the code so that the balls die independently of each other, not all at once. All right, that's it. You have your mission. Please accept your mission and start getting shit done. If you have questions, ask me. I'll come around and help as best I can. If you're on Zoom, chat me or voice in, and I will take a look. And if you need to share your screen, other people can share screens too. All right, question for me or for everybody? For me. Okay, I'll be right there.